Our solution consists of two parts. The first is the ensemble of 6 simple 1D convolution neural nets, and the second is the ensemble of 2 transformers. In this presentation, I cover only our part about simple 1D convolution models, and our teammate will talk about his part after me. The key points, about our background. Me and 2 other members of our team work at the company FreeFlex, which develops mobile.
Uh-oh.
Also,
Sorry, you dropped there for a second. Can you give us the last 30 seconds?
sorry, do you hear me?
Yes, we hear you now. You just started the slide when we had you drop.
We work at a company FreeFlex, which develops mobile applications for sports with usage of computer vision. We are responsible for the machine learning and computer vision. We develop our computer vision using TF Lite. Did you hear I spoke about that? About
Yes.
that slide?
Yes.
The key points are data preprocessing, heavy augmentation, and ensembling. We use TensorFlow Keras with a few classes from PyTorch to work with data loader. And training of all our models takes around 1 day. For local validation, we split dataset to train and test set by participant ID. We also didn't use depth dimension, only X and Y. We replaced all not numbers with zeros. No future engineering. We didn't add additional data like distance between points, motion speed, and etc. We didn't throw away frames without hands. We used a different combination of parts for different models: hands, lips, eyes, and paws, the top part of paws. For some models, we used only every second point of lips and eyes to prevent overfitting. And we took only 32 frames for all models except for one where we used 96 frames. For normalization, we used 7 points from body and lips and eyes. We normalized for all frames in the video. We used only one hand. If the person on a video is left-handed, we flipped the points and mirrored horizontally their coordinates. We used cross-entropy loss, simple Adam optimizer, cosine annealing scheduler for up to 1,000 epochs. No label smoothing, no focal loss. As augmentation, we used shift, scale, rotations, applied globally for all frames. Random small shift added to every point. We also used combining of parts. We took a hand from one sample and lips from another sample with the same label. And this augmentation gave a significant increase in score. We also used cut mix, took part of samples from different classes. And for the sample where we took hand, we used label 0.7, and for other parts we used 0.3. We initially tried to develop our own solution based on the public transformer, but then we found that architecture of a model didn't matter as much as proper work with data and assembling. So we switched to more simple architectures like 1D convolution multi-layer models. We used Keras and utilized all the advantage of native TF-Lite layers like depthwise convolution. This is what our typical model looked like. We used sequence of 1D convolution blocks with usage of depthwise convolution. For ensemble, we used slightly modified variants of the model. Also, we had enough time to do test time augmentations. So we used random left-right padding for short sequences. And for large sequences, we drop frames where there are no hands with more high probability. These 1D convolution models were fast and lightweight, so we could assemble up to 6 models and still had space and time for additional models and test time augmentations. Ensemble of 6 such models got 0.79 on public leaderboard and 0.87 on private leaderboard. When we decide to collaborate with another participant of the competition, we merge our models, and our combined model placed third in the competition. Thank you for listening. That's all.